Hey, good afternoon, folks. Let's get back to the Pythagorean theorem in the series. What I want to discuss today is IXL Y.2. Your assignment is finding the missing leg length when giving a right triangle. So let's look at a problem. All right, so this is the situation. We have a right triangle where your leg A is 3, the hypotenuse is 5, and on side leg B, there's an X. Let's see this right here. Okay, so first thing you want to do is use your formula, of course. A squared plus B squared equals C squared, which is here. Now we're going to go through it step by step. First thing you want to do always when you're doing these problems is write your formula. A squared plus B squared, so step 1, A squared plus B squared equals C squared. Now after you write that formula, then you want to is step 2, substitute. What I mean by that, we want to substitute the values in for A, B, and C. So from the problem, the value for A is 3, which is here. The value for B, leg B, is here, which is X. We don't have a value. We're trying to find this side. So that's why it's X, because it's unknown. And for the hypotenuse, which is here, C, we got a 5. So we substitute a 5 in here. So this is the substitution portion. Now step 3, the third step, is you want to solve. So this is what we do. We square the 3, which gives us 9. We can't square the x because there's no value here. And the square of 5 to the second power is 25. Now we want to solve this two-step equation. The first thing we want to do is approach the weaker portion, which is here. So we're going to do the opposite of the 9. So we're going to subtract the 9 from both sides. These 9s will cancel out. You bring down your x squared. 25 minus 9 is 16. So x squared is equal to 16. But I don't want x squared. I just want x. So the opposite of the square is the square root. So we have to take the square root of both sides. Doing that, the square root of 16 will give me 4. So the missing side, leg, here that's missing, is 4. Okay? So that's how you find the missing leg. So let's do another problem. So here we have a situation where leg B is missing. Right? No, excuse me, leg A. So let's go through the problem. Same steps. Again, we write the formula. A squared plus B squared equals C squared. By substitution, A squared, because there's no value here for A. B squared, this time the value is 5. And our hypotenuse is 13, which we put here. Now, once we substitute that in, we get this two-step equation that we're going to solve. So you do the opposite of what you see. So if I have a plus 25, that means I have to subtract 25 from both sides. These 25 cancels. You bring down the a squared. 169 minus 25 is 144. That's the first step. The second step, since I have a square here, to undo that, I take the square root, leaving me with the a. And the square root of 144 is 12. So this missing a here is equivalent to 12. Now, let's do a check for this one. Let's check this when a is 12. So on a check, the first thing you want to do again is rewrite the formula for Pythagorean theorem. A squared plus B squared equals C squared. Second step, we're going to substitute in the values. So we're going to put in a 12 here because we found A to be 12. B is 5. And if this is correct, it should come out to equal to c squared, which is 13 in this case. Third step, we want to start to evaluate this. So 12 squared is 144, 5 squared is 25, and 13 squared is 169. So when you're checking, both sides should come out to be equivalent if you did it right. So here in step 4, when I add 144 and 25, I get 169, which is equivalent to what was on the other side. So 169 equal 169, so it checks out. Okay, that's how you do a check for these problems. I want to show you just one more to solidify your learning. One more example. So we have this one here where the hypotenuse is 10. We have a leg here which is 9. And again, this other side is unknown, so I put an X. Following the steps, again, you have step 1, you write the formula. Pythagorean theorem formula, a squared plus b squared equals c squared. Then we start number 2, substitute. A is 9, so it's 9 squared, plus b, the other leg is x, so it's x squared, equals c, 10, which is 10 squared when I plug it into the formula. Squaring the 9 to the second power is 81, plus x squared, there's no value for x yet, equals 10 squared, that's 100. This is called a two-step equation. Solving this, start with the opposite. So the opposite of positive 81 is you minus 81 on both sides. These cancel over here. You're left with the x squared. You bring it down. This here, 100 minus 81 is 19. So to solve for x, you just take the square root because that's the opposite of the square. That gives me x here. And the square root of 19 is this long decimal number, 4.3588989435, etc. Now, we don't want all of that. So in this case, I just want to round it to the nearest tenth. And if I round that to the nearest tenth, we get 4.4. Why 4.4? Because 3 is in the 10th column. 5 is right behind it. It tells you to round this up 1. And thus leaving you with the answer of 4.4. Hopefully you understood that and you have much success in tackling these problems on IXL. Take care.